We use a lot of different tools at AppsSmith, and we're always looking for ways to improve our processes and automate tasks. But sometimes, depending on the tool, maintaining that automation can feel like more work than it's actually saving you. Have you ever had to work on an automation that looks like this? Yeah, just trying to find the right node to edit can be a challenge, especially when working on an older automation that you haven't viewed in a while. Well, check this out. At AppSmith, we've solved this node-based nightmare with a code-based workflow builder. AppsSmith Workflows are like an app without a UI that runs on your AppSmith server. They can still connect to all the same databases and APIs, but without needing to run in the user's browser. AppsSmith Workflows are code-based instead of connecting nodes like other automation platforms, which ends up being a huge productivity boost, and it makes the app easier to maintain. Let's check out a few examples. Here we have two workflows in Make that we were using to auto-label issues in GitHub and integrate with our support team. But they were difficult to maintain and required a new node for every label. By replacing these with a code-based workflow, the labels can be passed dynamically without needing a new section for each new label. The new workflow is around 100 lines of code and much easier to maintain because everything is in one file. And here we have two more workflows that were used with our support bot. This was around 40 nodes using 27 different Make integrations. By converting this to an AppsSmith workflow, only 15 integrations were needed. The actual data sources without all those extra steps for transformers and filters and routers. Now, that's nearly 100% improvement in efficiency and maintainability, and everything is in one file. AppsSmith Workflows can be triggered from an AppsSmith app or from a webhook or scheduled cron job. You can pass in data and then write your logic to take various actions based on the input. Where AppsSmith Workflows really excels is with loops. Running multiple APIs in a loop takes just a few lines of code, and if you want to add a new API, it's just a single line. And nested loops are much easier to manage. Looping over parent and child records is easy to edit from one block of code instead of having to expand multiple nodes for each table. All right, next up, we're going to check out the approval workflows or human-in-the-loop workflows. Another unique feature is the AppsSmith approval workflow or human-in-the-loop. These are automations that have a human reviewer step where the user can choose to approve or reject the job. Just add an assign request step to your code anywhere you want to add a human reviewer. Then the code will pause at that step, waiting for the user to respond. Once a request is assigned to a user or group, the workflow pauses and waits for a response from the assignee. These are long-running workflows that will persist their state and create a queue for the approver to review. Then you can run different logic based on their response. Now let's check out a use case. We checked in with our friends over at the agency, and they were telling us about this refund approval workflow. It started out where they had no controls in place and their support team was approving all returns and all refund requests. They found out they were losing a considerable amount of money because some customers were abusing the system. So initially their fix was to have the manager approve all refunds. This put a check in place, but then the manager became the bottleneck and it just took extra time from the team, delayed the ticket resolution, and just led to more angry customers. Then they figured out they could use AppsSmith Workflows to automatically approve the low-risk returns and only flag the ones that were a risk for fraud. By setting up dynamic values that they can adjust as needed, the workflow checks to see the amount of the order and how many previous returns that particular customer has had. If it's below a certain threshold, the automation will go ahead and approve the refund and update the database directly. But if it's above the threshold, the workflow pauses after assigning the request. It'll wait for a manager to respond and actually approve it, and then depending on their response, it can either finish the automation and approve the refund or notify the customer that it has been denied. If it's below the threshold, the workflow will just continue and finish updating the database directly. but if it's above that threshold, then it will add that reviewer step and request a response from a manager before continuing. The support team can trigger the request on any order, and then the workflow checks the amount and the customer's order history. At this point, the workflow is paused, and it can stay that way as long as needed for the assignee to have a chance to review it. The assign request step returns a promise that resolves whenever the user responds. Now, over in the admin view, the manager can review the pending requests and choose to approve or reject them after taking a closer look at the customer's order history. Then, the workflow takes over again and finishes with any updates to the database. All right, let's take a look at the app. Okay, first we'll take a look at the app that triggers the workflow, and then we'll look at how they're connected and then check out the workflow itself. So here we have a list of tickets that have come in, and some of these involve a return. Now, initially, the support team was just refunding everything and approving every refund, and the company was losing some money. So after the manager was tied in and they started doing the manager approval, that just became a bottleneck. And now what they have is a way to automate that check to see if there's a risk and to just instantly approve the ones that are low risk and only require a manager approval on the high risk requests. So if we test this out with one of these higher orders here, this one is over our threshold of $300. So I'm going to request a refund, and this will trigger the workflow. Now, under the hood, this is called the AppsSmith Workflow on the server side, and then that's taken over to do all the logic, checking the number of previous returns and the amount of the order. So let's look at how the app is connected. Now this request refund button here, we'll look at the on-click setting. You can see that it is updating the database to say that a refund has been requested, but it won't give the end user access to actually approve it. So we're capturing the fact that there was a request made, and then depending on the conditions, depending on the order amount and how many previous returns, this will trigger the workflow, passing in the customer ID and the order ID so that the workflow can go do all those checks. Now, this just triggers the workflow to start, and now we'll go and look at the workflow itself. So back to the workspace where this app is, there is a refund checker workflow separate from the app. So the app can trigger it and it starts the workflow, and then things happen in the background and wait for that user to respond. So we'll look at the workflow itself. The data gets passed in. So we send in data that has an order ID, an amount, and a customer ID. The first thing it does is check eligibility for the return. So based on the number of previous requests that this customer has made, we can determine if it's over our threshold of 3 previous refunds or if the amount of the order is over $300. If it's below that threshold, it'll just go ahead and approve it. There is no human in the loop required, and the refund gets approved and it's over. Now, if it's above that threshold, in either case, if it's over 300 or 3 or more previous returns, then it assigns a request. This creates a pending request that is waiting to be resolved. Now, these are long-running workflows. This will stay paused on your AppsSmith server. It maintains that state, and it will be there indefinitely, waiting for the user to respond. So you define a response and await that request. Once it's eventually resolved from the end user, it will go on to the next step, and then you can have branching logic based on their response. So if the user approves, then it will go ahead and run the approve order query, passing in that order ID and amount. However, if the manager chooses to reject that one, then it updates the database saying that that particular refund was not approved. So lastly, we'll go back to the app and see how the end user can actually trigger that approval or rejection. Now, there's the end user view here for the support team, and separately, there's a refund approval page for that admin user. So here, the admin user can come in and review the extra details. They get a log of how many previous requests that user has had and what's the amount of this order. So here we can see that all of these are asking for approval because the amount is over 300. If we had any previous requests, we'd see that here as well. And then there's metadata showing the rest of the order data so that the manager can make a decision and decide whether or not to approve or reject this particular workflow. Now, lastly, we'll look at the app editor here one more time to see what happens when we click that button. We have a resolve button here. This is a menu button, so it has multiple options. The approve one will run resolve request, and it passes in the resolution parameter of approved. So you can imagine the reject button is very similar. It's running the exact same query, just using a different parameter here. And so if we look at the resolve request API here, we're just referencing this.params.resolution. So the exact same query can approve or deny it, and you just pass in the parameter. As you can see, this code-based approach to workflows makes your automations more flexible and gives you complete control to write any logic you want using JavaScript. Now let's check back in with Kevin and see what's up next.